All right, thanks, Rocky. So today I'm going to be talking about the Docker deployment of the ITOM suite from Micro Focus. Our agenda, I'm going to go over the underlying technology. The two main ones are Docker and Kubernetes. What are they? How do they start? How old are they? What are the advantages of these technologies? And how has Micro Focus utilized these technologies? And then a container deployment methodology versus classic deployments. We'll talk about that a little bit. And then how will future upgrades be affected? So what is Docker Kubernetes? So these are the underlying technologies around the container. So I'm just going to talk and give you a little background on these technologies. So maybe you'll understand a little bit better where they came from and what the advantages are. So Docker is a company that's driving the container movement across the enterprise. It was officially launched March 13th, 2013. And Kubernetes is an open source platform developed primarily by Google, and it's for managing containerized workloads and services. And this was released officially July 21st, 2015. You can see both of these, it's 2018, so both of these technologies are still fairly new. They've only been around for a few years, but the adoption rate on these is incredible. So most of my colleagues or friends that are developers, like straight up Java or .NET developers, are using these technologies in a lot of their new projects. So, and they really were started by developers developing applications and wanted to deploy them more easily. So the adoption really has taken off from the development side. So what are containers? So container image is basically a lightweight standalone executable package of a piece of software that includes everything it needs to run. It's got the code, the runtime, the system tools, system libraries, and the settings. So containers isolate software from the surroundings. So for example, differences between development and staging environments, and it helps to reduce conflicts between teams running different software on the same infrastructure. So basically, you can deploy containers to your dev, your QA, your production, and you don't have to really worry about what's the underlying hardware look like, or what's the underlying software look like. Do I have the right packages loaded on there? Do I have, in the Windows world, is IIS set up right? All these different things, because everything that you need is contained in the containers. And this is just a screenshot right off a Docker website of explains a little bit how the containers might look and what's in the containers. So you can see that these containers are all running on top of the same kernel, the same operating system. The first container's got Tomcat, Java, and Debian. The second container's got PHP, MySQL, and Ubuntu Linux. And the third container is static binary and Alpine, and they're all running on the same kernel. So all three of these containers could run on the same machine with these myriads of software. So one of the big advantages is that you can share hardware across these containers and not have the conflicts that you would running these applications on the same machine independently. So what are some of the biggest benefits of containers? Well, they're lightweight. So containers share the underlying operating system kernel, and they use less CPU and RAM than apps installed on individual machines. So like in the ITOM instance, you can share underlying operating systems resources that normally you wouldn't be able to. So maybe you would never load the web tier and the service management RTE on the same box in production. But with containers, they can run on the same machine, and they'll actually be spread across multiple machines. So perhaps you might have 5 production servers, and those 5 production servers might all be running the web tier and the service manager RTE. But they're all separate. They don't even know that each other exists on the same hardware. Standards. So they're all based on open standards and run on Linux, Microsoft, and cloud environments. So it's really helpful for deployment of applications, because you can deploy applications across Linux, Microsoft, and cloud. And there is some conflict between Linux and Microsoft. They're still working out, and I had some slides on that I actually pulled up for this presentation to keep it short. But if you're interested in that, there's a lot more information out there about running Microsoft and Linux containers on each other's operating systems. So insecure. So Docker containers isolate apps from each other and the underlying infrastructure. So Docker containers, the underlying infrastructure doesn't really even know what's in the Docker container, and there's no way from the underlying infrastructure to get into these Docker containers. So malicious applications on the underlying infrastructure can't really affect these Docker containers. They can't get into them and see what's in them. They really are isolated from the infrastructure and the operating system. And also, if there's something, some malicious software in the container, it doesn't really have access to any of the underlying infrastructure's, say, operating system files or hardware. So there's no way to format a disk or delete files from the underlying operating system from these containers, because these containers just don't know that that the hardware exists underneath them. So how are containers different than virtual machines? Because virtual machines is what most people is running right now, and containers is a little bit different conceptually. So on a virtual machine, the software must be installed on each server. All the prerequisites must be loaded on each server for that software. Conflicting software can't run on the same machine, and each additional software install requires a new OS waste CPU and memory. In containers, instead of booting an operating system, you just start the container, so that they do start quite a bit faster than virtual machines. In the Docker environment, only the Docker software must be installed on each machine. And like in Linux and Microsoft, it's a very, very simple, a lot of Linux distros come with Docker installed. Microsoft, it's PowerShell script to install Docker, so it's very little software to install. It's almost part of a standard build. So if you're building a big Microsoft infrastructure, you would just have a very lightweight kernel with the Docker installed. And Linux, you can have also very lightweight kernel with the Docker package installed. Conflicting software can run on the same hardware. So if you've got two pieces of software, especially on the Linux side in the Java world, a lot of times you'll have software that cannot run because they need different versions of Java. Well, Docker containers, they can run on the same machine because the version of Java that they need, or the little bits of Java that they need, are actually bundled inside of the container. And you don't have to worry about mismatching your Java versions. Even multiple instances of the same software can run on the same machine. So you can have different versions of the same software running on the same machine because they're not crossing up DLLs and Java jar files and things like that. Software prerequisites are packaged in the containers and do not need to be loaded on the underlying machine. So instead of building a separate machine for each application install like you do kind of in the virtual machine world, basically you're just deploying a Docker package to that machine or a single machine until you run out of resources, basically, and then you build another machine and deploy Docker packages to that. So it's just a lot more efficient. So why do developers love containers? So it's super easy deployment. So I can write let's say a .NET app and deploy it to any Windows server running Docker, Azure, Amazon, AWS, etc. There's not a lot of setup. As long as the environment I'm deploying to is running Docker, my app will run, because everything is in my application. It is in there. So if I deploy to Amazon Web Services or Azure or a customer's site, as long as they've got, for this .NET app, as long as they've got Windows running Docker, it will work. So it's pretty amazing for deployments. It really shortens deployments time a lot. And no more installing all the prereq software needed by each machine. You just deploy the Docker container. So it's super easy for deployment. Same thing with Java apps, and kind of the same concept for these micro-focus applications. It's a little bit different. I'll get into how micro-focus uses Docker in a little bit, but the underlying technology allows for super easy deployments. This is just a little screenshot of the old way where applications run on the host, and the new way of on the right where we deploy containers. So on the left, if you look, you've got your applications running on top of your libraries, sitting on top of your kernel. And you can't have applications that don't work together. They have to share the same set of libraries. So if you've got newer or older libraries sitting on top of your kernel, say your Java version or your .NET version in Microsoft, that right version has to be there on that machine. When you deploy containers, your apps and your libraries are deployed together on top of with the container on top of the kernel. And they are lightweight. They do use the underlying operating systems, very basic core, say file system services, for writing log files, all those kind of low-level API type services. They do pull out of the kernel and use those. So it's pretty slick. You don't have to have those in your Docker containers because if they're in the kernel, you can use them in the kernel, which makes the Docker containers more lightweight. So what is Kubernetes? Kubernetes is basically a container-centric management environment. It does the orchestration between computing, networking, the storage infrastructure on behalf of the user workloads. So Kubernetes is not a traditional all-inclusive platform as a service system, but it does provide some general availability features common to PaaS, such as deployment, scaling, load balancing, logging, and monitoring. So Kubernetes is important because Micro Focus uses it pretty heavily in their deployment of the ITOM suite. In fact, most of the management that you'll do of the ITOM suite, you'll do via Kubernetes. So how is Micro Focus utilizing Docker and Kubernetes? So the applications are being containerized. So they're taking the applications that they've got, Service Manager, UCMDB, all the chat service, collaboration, all those applications are being containerized. Each container contains a microservice, i.e. the Service Manager RTE, the chat UI, the chat service. They're all little microservices. And when you deploy this, you'll see you have to log into Docker site and download these containers from the Micro Focus Vault on Docker, and you'll see there's like 110 microservices that download. So every little piece of executable code has been broken off into its own micro service, and of course they're all orchestrated with Docker or with Kubernetes. So Kubernetes is used to link all the microservices together. So deployment of the suite includes all the microservices integrated and working. So that's one of the beauties of deploying with Docker. So you can deploy with a single, like if you look at the demo system, deploying a demo system, you can deploy Service Manager, Chat, Service Portal, UCMDB. You can deploy it all at once to basically 2 servers, kind of the minimum is 2 servers. So you can connect to an external like Oracle database from there, or use an internal database, a Docker containerized database, but you don't have to do all the installs of all the different products. You can basically just deploy them all right from one little website on the machine. So what's the process? I'm just going to go over the process to install the ITOM suite so you can kind of see the steps. So if you're thinking about deploying this containerized version, what are the steps that you're going to have to do to get this to work? So you deploy the requisite number of Linux servers. So right now, the containers really only run against Linux. So all the containerized processes are run on Linux. We're a Microsoft shop. Basically, we run Hyper-V. So I'm running Linux on top of Hyper-V, and it works fine. So I think eventually, probably in the next year or so, you'll see Microsoft support of native Linux Docker containers right on Microsoft. Just the way that Microsoft works with Docker containers, I can see that coming pretty easily. So you deploy that number of Linux servers. The minimum is 2. You got to have 2 of them at least. Then you download and install the Container Deployment Foundation on the primary Linux server. So the CDF, I'll refer to it as the CDF, is basically Micro Focus's deployment, the way that you can deploy these Docker containers in Kubernetes. So you need to download that CDF because it contains all the scripts and everything that you need to download the Docker containers and deploy the Kubernetes and deploy the Docker. It has all the scripts in the CDF. So you deploy the CDF to the worker servers via the CDF web interface. So once you install it on Linux, there's a little install you run, creates a little web interface that you go in, and then you can deploy the CDF to your worker or secondary servers. And I tell you what, the newest version that was released in February, it's really slick. It's the best version of the CDF yet. Really easy to deploy to the worker servers. I've never had a problem deploying to the worker servers in this newest version versus the other versions, so it works really well. Then you download the Docker images from the Docker repository. So Micro Focus has their own repository. You have to get access to it from Micro Focus in order to download these images. And then once you download the images, you upload them into the container suite. There's a little upload image shell script you run, and then you just you fill out some NFS shares, and you click a button, and it deploys all the applications for you to Docker. So it's pretty slick. It's pretty simple. The time frame to deploy CDF, it takes some time to download those Docker containers, a few hours. If you've already got those, it takes the longest time actually is just uploading those Docker containers like into the CDFs, like memory banks, to be deployed. That might take a couple hours. But you can easily deploy, pretty easily, you can deploy all these things in like a demo system in a day, especially if you don't have to download the containers if you already have them. So advantages over traditional deployments, suite components already deployed, already connected to each other. It's especially helpful in like for service portal, for chat. I mean, there's a lot of these different suite components where if you're installing the entire suite, that you've got to install these things separately and then get them to work all together. You know, with certificates and lightweight SSO and all those things to get all these different applications to talk to each other. Well, that's already deployed via Kubernetes with these Docker containers. Resources are spread evenly between the computing resources. So normally lightly used applications like the chat service, you don't have to build a chat service server. Yeah, you don't have to worry about building specific servers for specific applications at all. You just build Linux servers. In the case of ITOM, you just build Linux servers and install the prerequisites on them, which really isn't very much. Like on the master server, you need zip, so you can unzip the install package. But there's really not much to install on the secondary servers. It's basically just your standard Linux deployment. And everything is spread across those servers. So if you've got 4 servers, all the applications are spread across those 4 servers evenly. And you don't have to worry which one is my chat service server, which one's my Apache server for my web front end, which one's my portal server, or my UCMDB server, my service manager server. They're deployed across all the servers. And containers can be moved from machine to machine. So you can actually move, if you've got a machine that's running a high load, maybe some overnight UCMDB script or something like that, and it's interfering with Service Manager, you know, these containers can be moved from one machine to the other. And you can even add machines. You can just start plopping more machines in and just start deploying to those machines to scale out. So really easy to scale out with Docker. You can literally just add machines to your pile and just keep deploying containers to them. So, you know, very fast to deploy extra capacity. The containers don't have any state information, and you can just take them down and recreate them on any resource, and they'll work. You know, they're not reliant on anything that's on the specific machine. So you can move containers around from machine to machine, and there's really nothing that they're reliant on. You've got static information that's stored on network shares, maybe on a SAN, but you know most of the ITOM suite information is stored in a database. So you're going to be storing most everything in a database. There's a few things that are stored on the NFS, but there's really not that much. Like I said, new resources can be added on the fly. You can add new servers during high use time without installing the application software. You just add the hardware and deploy the containers to it. So it's really slick. I don't have a lot of experience in the ITOM suite and high like a high volume production environment and how easy it is to deploy. Like I don't know for sure if the containerized suite auto deploys to new servers based on usage, or if you kind of have to do that yourself. Still learning a lot about that, about how it handles high loaded servers, things like that. So Micro Focus specific info. Most of the ITOM suite is containerized. There's a few exceptions. You seem to be the Windows, the agent server, not containerized, is on the roadmap. And you can mix traditional deployments with containerized. So you can deploy Service Portal on Docker and connect with Service Manager in a standard deployment, or Service Manager on Docker, connect to using UB. So you can mix and match with traditional deployments and containerized. So I think pretty typical, probably the roadmap for a lot of customers is going to be deploying Service Portal on Docker, because if you want to run Service Portal, the newest version of Service Portal, you can only get it on Docker, on the CDF, containerized. So I think a lot of companies will probably start with that and then move into the other modules. So currently, SQL Server deployments of UCMDB or Service Manager are not supported. Only Oracle supported. So, and part of that has to do with right now the containers are only deployed on Linux. So, and there isn't really a great solution for Linux to connect to SQL Server. It's just not, I know there's solutions for it, but it's just not common. So right now, Oracle is the only thing supported. Windows deployments are not supported for Service Manager and UCMDB. So like I said, they're only containerized Linux right now, and they must be run on Linux. So I'd say in the near future, if you're Windows, like a Hyper-V shop, probably you'll be able to deploy these on probably a very super lightweight kernel on Windows and to be able to run the install for CDF. Right now, they must be run on Linux. But especially for an Oracle shop running on Windows, it doesn't matter if you're deployed on Windows or Linux or containers. I mean, you just connect to Oracle and they all work the same. It's all the same binary build. So you don't have to worry about, right now if you're running on Windows and I'm on Oracle, can I go to containers? Yes, you can. It's the same binaries, just deployed a different way in containers. Because the containerized versions are identical, you can move items either in containerized environment or move them out of containerized into a standard deployment. So, like I said, you can, like if you're on Service Manager on Oracle, you can run containerized, you can run binaries on Linux, you can run executables on Windows. It doesn't matter. Just connect to your Oracle database. They'll all work the same. Things, INI files, log files, held in non-containerized places, NFS shares, Oracle databases, etcd files, Postgres database. So, and like I said, Service Portal, the newest version, only available in containerized. So this one right now is the exception. There is no standard build for this product. You have to run it containerized. CDF upgrades. Previous versions needed a complete uninstall, reinstall the underlying CDFs of the Container Deployment Foundation, so that there wasn't a real easy way to upgrade to the next version. So I've installed this February release, and it is quite a bit different than the other releases, and Micro Focus has said that the February release is the one where you will not need to uninstall and reinstall the CDF in order to upgrade to the next version. And I can see the bits that are in place for that when I installed it. It's kind of a different install process than the other versions, quite a bit different actually. And you can I can definitely tell what they're doing there to try to prepare themselves for upgrades without having to uninstall, reinstall. So for future upgrades, for most products, the upgrades are going to be pretty simple. You download the new Docker images and you just deploy them. And so you don't have to uninstall the old binaries or reinstall or change your directory structure to copy the new old binaries in there. I mean, it really is very simple to deploy these. They have a little web interface to deploy the Docker images to download, and you just click the upgrade button and it upgrades them. So, of course, some products may need minor work for application upgrades. And Service Manager, you still are going to have to do your internal application upgrades. Those are getting easier and easier. I can tell you, going from 940 to 960 right now. I mean, the application upgrade is, there's just not a lot of code merging left that you need to do. So it really simplifies the binary deployment of the application. But if you do have some code merging to do, you're still going to have to do that. But a lot of the deployment issues for upgrading are going to be gone. And it's so easy to do binary upgrades in Service Manager. Maybe you're upgrading applications every 3 years or so. Your binary upgrades, whenever they come out, it's super easy to deploy. So a lot easier to deploy to testing environments, get it tested, make sure everything works, and just deploy to production. You can deploy in minutes, these new binary upgrades. So yeah, like things like SRC, you may have branding that may need to be migrated, if you're doing the SRC. SRC is kind of being replaced by Service Portal. So can you use your existing Docker infrastructure? I'm going to kind of speed up here, but basically no. You have to use the micro-focused version of Docker and Kubernetes. So if you've already got a big Docker Kubernetes infrastructure and you're standardizing on specific versions, maybe you can, but you probably shouldn't use those versions for the Microsoft Focus suite. So there's some advantages and disadvantages. The biggest advantage is you don't have to have a Docker infrastructure to run this thing right now, because everything is contained in the CDF and deployment. So you're not just deploying Docker containers to your existing Docker infrastructure. And if you don't have one, so this makes a lot of sense. But if you're already a big Docker shop, you still got to use a CDF. So there's the upsides and downsides for different customers. So some final thoughts: each version of ITOM has gotten easier to install and has had less install problems. This last version specifically is pretty smooth. Managing the CDF infrastructure is quite different than managing the standard deployment. So your infrastructure team, they might have a learning curve in order to manage this versus just managing binary sitting on Linux or Windows Server. And if you do have some Docker expertise, you're definitely at an advantage just because the Docker and Kubernetes commands to get logs and things like that are standard. So you can use that knowledge to do management of these Docker containers. You can kind of manage them just like your other Docker containers. So if you do have that experience, that'll really help you. So if you have questions, my email address is there. You can email me questions after if you want.
Eric,
I don't mind.
I've got one quick one for you. So, is there any reason why I shouldn't be going to Docker besides the platform compatibility issues going forward?
So was the question, is there a reason why I should or shouldn't go?
Shouldn't. I mean, why wouldn't anybody move into the new Docker approach to making? It seems like it's going to be much more secure, easier to maintain, and all that kind of stuff.
Yeah, I think the biggest reason is if you're not an existing Docker user, simple things like monitoring, is the application up or not, may change in your environment depending on how you're monitoring it. So if you're monitoring a Windows service, say, or a Linux service with monitoring tools, that's probably the biggest change from an infrastructure side, is monitoring this whole thing, because now everything is in containers. So it depends on how you're monitoring. If you're monitoring with API calls, basically to see if things are up, that'll work the same. But if you're monitoring by looking at like ps-ef on Linux or services on Windows, you'd have to change your monitoring. So that's probably going to be the biggest leap. The other thing would be is if you're 100% Windows shop and just don't have any Linux expertise, these only run on Linux, and you do need some Linux expertise in order to get it installed, things like that. So if you don't have any Linux in your environment, it would be a pretty big jump. But other than that, everything else is better. But so some underlying infrastructure issues, but other than that, I would definitely recommend going to it if possible.